Hello students, welcome back to my YouTube channel Datasha. We are starting a new series of hypothesis testing. So this is the first lecture in which I'll be describing about hypothesis and the various types of hypothesis. So first of all, let us consider what is tests of significance. It's a very important aspect of the sampling theory. It's the study of the test of significance which enable us to decide on the basis of the sample results if the deviation between the observed sample statistics and the hypothetical parameter value or the deviation between the two independent sample statistics. It is significant or might be attributed to chance or fluctuations of sampling. This means that if we are talking about the sample statistics, that is the mean or the standard deviation, then in that case what would be the difference between the observed mean and the hypothetical mean that is given to us in the question, or the difference between the two independent means available for a particular samples. So a statistical hypothesis is a statement about parameters of one or more population. So parameter could be anything. It could be the mean, standard deviation, anything which is given to us in the question. So hypothesis is of two types. The first one is null hypothesis and the other one is the alternative hypothesis. Null hypothesis is the hypothesis which is tested for possible rejection under the assumption that it is true, and it is denoted by H naught. So we always denote our null hypothesis by H naught, and the alternative hypothesis is the complementary of the null hypothesis, and it is always denoted by H1. Alternative hypothesis, on the other hand, is one-tailed or two-tailed. Now, one-tailed means it could be either H1 is mu greater than mu naught or mu less than mu naught. Whenever mu is greater than mu naught, this is known as right-tailed hypothesis, alternative hypothesis. And whenever this is less than mu naught, this is known as left-tailed alternative hypothesis. Two-tailed means that if our hypothesis H naught is mu equal to mu naught, that means we are saying that the value of the mean which is given to us is equal to the hypothesized value, then it becomes the null hypothesis, and the alternative hypothesis would be its complementary, and it would be either it would not be equal. If it is not equal, it can be greater or it can be less. So whenever in the question we are having greater or less in given in the question, then it becomes a one-tailed alternative hypothesis. If in the question it is given it is not equal to mu naught, then it becomes a two-tailed alternative hypothesis. So we'll be considering a few examples so that you can find out how we can write the null hypothesis and the alternative hypothesis. So consider a random sample of 100 carpenters produces a sample mean of $15 with a standard deviation of 2. So here we are taking a random sample, and this is the sample mean and the standard deviation of the sample. We wish to show that the average hourly wages of the carpenters in the state of USA is different from $14. That is the national average. We have to write the appropriate hypothesis. So we have to consider here that this is the national average. National average means that it is the mean, mu. We always know national average means we are talking about mean, and national means we are talking about the population mean. So population mean is nothing but mu. So that means we are talking about mu here, and we are saying that mu should be different from $14. That means if we wish to write the appropriate hypothesis, so we can define the null hypothesis as mu is equal to $14 and H1 would be mu not equal to $14. We'll be doing how to solve it through different tests, Z test, T test, in the following lectures. So first of all, understand how you would write the hypothesis. How would you identify what is your H0 and what is your H1? So consider another example. A mean weekly sales of the candy bar in a candy stores was 146.4 bars per store. So the mean weekly sales, that means mean is given to us, is this. After an advertising campaign, the mean weekly sales in 22 stores for a typical week increases to this, and it showed a standard deviation of this. Now, was the advertising campaign successful? Write the appropriate hypothesis. So, was the advertising campaign successful? We'll be doing the different tests in this case, but what would be the hypothesis? So, let us define H0 and H1 here. So H0 is the null hypothesis. Mu is given to us as 146.4 bars. So H0 is that only. That's our mean weekly sales of the store. Now, after the advertising campaign, it shows that it increases to 153.7. That means now mu is not equal to 146.4, but it is greater than. That means mu is now greater than 146.4. So it is equal to 153.7. That means it is greater. So that means this is nothing but a right-tailed alternative hypothesis. So this is how we can identify through the question what would be our null and the alternative hypothesis. So consider the last example. A milling process currently produces an average of 3% defective articles. You are interested in showing that a simple adjustment on a machine will decrease P, the proportion of the defective produced in the milling process. Write the appropriate hypothesis. Again, we define our H0 and H1. Here we are talking about P. That P, an average of 3%. So they are denoting it by P, because we can see here it's denoted by P. So we are taking P to be 3%, that is 0.03. Now a simple adjustment will decrease P, so that means P is now not equal to 0.03, but it is less than 0.03. So this becomes our left-tailed hypothesis. So I have shown all the three examples how you can identify the null hypothesis and alternative hypothesis. In the next lecture, we'll be talking about the different types of errors and the other definitions that is required for the hypothesis testing.